Alright, in this video I'll be covering the integral x squared times the square root of 1 minus x squared. So pause the video now to solve this on your own. Alright, so you may be able to gather this is not a u-sub. U-sub's not going to work. And integration by parts won't work since you would have to derivate x squared and integrate the square root of 1 minus x squared. But the integral of 1 minus x squared is the square root of 1 minus x squared is also very complicated. So we end up seeing this is probably a trig sub. So let's try and do a trig sub here. So what we can do is we might be able to see, okay, so let x equals sine theta. So that would mean if we draw a triangle here, x, and then we'll have 1 here. By Pythagorean theorem here, we end up seeing this is going to be the square root of 1 minus x squared. So that would mean that square root 1 minus x squared is going to be cosine theta. Over here we can take the derivative to get our d theta, so dx equals cosine theta d theta. This is already isolated for dx, we can immediately plug this back in. So x squared is going to be sine squared theta, and square root 1 minus x squared cosine theta. Don't forget about our other cosine squared. So this is going to be cosine squared theta d theta. So this actually has a really elegant solution. So what we can do is we can first rewrite this as sine theta cosine theta squared d theta. Now remember our double angle identity rule. We just apply this in reverse for sine. So this is 1/2 sine 2 theta squared d theta. This works. We see this would be sine theta, 2 sine theta, cosine theta, the 1/2 will cancel. So we can move the 1/4 to the outside. So now we just have sine squared of 2 theta d theta. Alright, so now what we can do is we can use our power reducing identity, which you might remember for sine squared is 1 minus cosine squared, 1 minus cosine 2 theta over 2, and theta in this case is 2 theta, so this just is going to become 1 minus, don't forget our 1/4 here, 1 minus cosine 4 theta over 2 d theta. So move our 1/2 out, we just have 1/8 of 1 minus cosine 4 theta d theta. So we can just evaluate and we can just separate out these integrals. So the integral of 1 d theta is just going to be theta. So we have our first part, theta over 8. And then we're subtracting 1/8 times the integral of cosine 4 theta d theta. This is a pretty simple integral here. It's just going to end up being 1/4 sine 4 theta. So we see this works because when we take the derivative, we're just going to get cosine 4 theta. So this works here. But now the hard part is we have to convert this back to x. So we'll simplify this a little further first. Theta over 8 minus 1 over 32 sine 4 theta. So remember, x equals sine theta. So theta is logically sine inverse sine of x. Just take the inverse sine on both sides, the sine inverse sine cancel. So now we can substitute this back in. So first we have sine -1x over 8 minus 1 over 32 sine 4 theta. I'll just leave that there. It's going to be cumbersome to write out sine -1. So To fully get this in form of x, we're going to have to use more identities. So we're going to use the double angle identity first. So we have sine negative 1x over 8 minus 1 over 30, 1 over 16, since we have the 2, sine 2 theta cosine 2 theta. Okay, so now what we can do, we can move this more here. Over 8. I'll just rewrite this as 1 over 8 times sine, inverse sine of x. Minus, so we can apply this again. We get 1 over 8 sine theta cosine theta. This one is cosine 2 theta are double angle identities, cosine squared theta minus sine squared theta, so we can put that in here. Alright, so we just have 1 over 8 sine negative 1x, sine power of negative 1x, minus 1 over 8. Okay, so now we can finally use our theta here. So sine of inverse sine of x, that's just going to be x. And the cosine is cosine of theta, where theta is sine negative 1 of x. We have to remember this is just going to be the square root of 1 minus x squared. And we can draw the triangle to verify this. So cosine squared of that is just going to be the square root of 1 minus x squared squared, so that's just 1 minus x squared. Sine squared theta can be rewritten as sine theta squared, but we know sine theta is just going to be sine of inverse sine of x, so just x squared. It's just going to end up being x squared, so this is 1 minus 2x squared. So now we can write our final solution. So we have 1 over 8 inverse sine of x minus 1 times 1 over 8x square root of 1 minus x squared, and minus 2x squared. Multiply those out. The negative will cancel, so it's just 1/4 x cubed times the square root of 1 minus x squared, and don't forget our plus c. So I hope you enjoyed this video, so make sure to subscribe to the channel if you want to see more math videos.